So the term electroplating is the process of covering an object in a layer of metal by hydrolysis. This technique is widely used in various industries, usually to enhance the properties and appearance of the materials. The electroplating system consists of several key components, which include cathode, which is the object to be plated, anode, the plating metal, electrolyte solution, a salt solution containing metal ions, and electrical current, which is the energy source that drives the process. The process of electroplating works as the cathode, which is placed in the electrolyte solution containing positively charged metal ions of the plating metals. The anode is also placed in the solution. When an electrical charge is applied to the solution, due to opposite charge attracts negatively charged ions, the anions move toward the anode and positively charged ions, the cations, move toward the cathode. This results in a thin metal coating forming on the object, and this is the process of electroplating. This technique is primarily applied to modify the surface of metal by combining other metals, and usually to prevent corrosion, abrasion, or for decorative purposes. It also allows the use of inexpensive material inside and electroplate a different type of metals to achieve the desired properties or appearance. One application of electroplating is aerospace, where the metal forms the component of airplane are electroplated. This is to add an additional metal layer which defend extreme temperatures and environment during the flight. This helps to slow down the corrosion and increase the lifespan of the airplane. This layer of electroplating is often named the sacrifice layer, as it is used to protect the inner layer. The electroplated material here is often chromium. Electroplating is also widely utilized in jewelry industries, where precious metals are electroplated by designers to enhance the appearance and durability of metals. For example, copper and silver are sometimes electroplated onto gold to create a rose gold color, which are very popular among costumers. People who are involved in electroplating are at risk as there is chance of exposure to hazardous chemicals. The, ha- the hazardous chemicals here include heavy metals such as zinc, copper, or chromium, which are toxic and can cause health issues including cancer. Also, acid will also be formed and used, including hydrochloric, nitric, sulfuric acid, which are both highly toxic and corrosive. If it is exposed, there is chance of eye and skin irritation and respiratory problems. Arsine gas will also be presented when acid contact with solution containing arsenic ions. Solution presented with arsenic ions during electroplating may include anode and specific type of acids such as hydrochloric acids. The arsine gas is also highly toxic and will cause severe poisoning. Metal dust will also be formed and will lead to respiratory problems if inhaled. The exposure to hazardous chemicals created during the process may cause both long and short-term health problems. A short-term exposure may cause health problems such as burn, eye irritation, throat lung problems, and a consistent exposure may lead to even more severe health problems such as nerve disorders, asthma, and even cancer. Despite from hazardous substance, there are also risks from electrical hazard, where insulator damage, corrosion on system part may happen and could cause an exposure to electrical current. Hazardous noise will be generated and lead to a risk of hearing issues. Risks also come from manual handling, where the process involves lifting heavy mechanics, possibly leading to strain injuries or slipping. There are a few main times of electroplating when the operators are likely to be exposed under hazardous chemicals. During handling and transport, fault operation may occur, such as chemical spill during the process of storing, transporting, or disposal. During water disposal area of electroplating, exposure happens when chemicals are not being neutralized and disposed, or it is disposed without approval from local Department of Environmental Protections. This may cause the exposure to citizens, not only the exposure to the operators. During the operation process, there are chances that operators is exposed to the anode when grinding. Such metal dust could be inhaled. Also, when excessive hydrogen or oxygen is emitted, or excessive bubbling occurs on acids, they create a hazardous chemical atmosphere which will create the exposure of chemicals to the operators. The law states that work environment should be provided and maintained in which workers are not exposed to hazards. The risk can be reduced in several methods. Safety trainings, which to train workers and making sure they have the ability to identify hazardous substances and they can assess the rate of injury in their own health situations and follows all the safety instructions. Wearing personal protective equipment, including goggles, lab coat, chemical resistant gloves, mask, and menstruator involved to limit the working time of workers and the containers must be fully labeled. Also, risk reductions, which to eliminate a hazard or chemicals if it is not required during the process, or there is a safer plan for substitution. The laws say that health surveillance must be applied at no cost to the workers. We're frequently monitoring individuals' health situations. It must be supervised by a medical specialist when is well trained for monitoring health situations due to hazardous substances. Specific toxic chemicals must be tested if there are chances of being exposed. This figure shows the nickel exposure level of urinary for workers. So chromium and nickel compound are mainly excreted from urine after absorbed, which make the graph about the level of nickels and chromium in workers' urine a great demonstration of the amount of hazardous substances workers usually absorb during work. And by this graph, it is shown that workers are being exposed to an amount of nickels, which is a toxic chemicals, demonstrating there are actual risks of electroplating. This risk of being exposed to heavy metals can be reduced by biomonitoring. The working habit of the worker can significantly increase the rate of chemical exposure. Biomonitoring provides feedback loops, which provide direct feedback to the workers by tracking them to increase the awareness of the workers, thus lowering the rate of exposure. An alternative way of electroplating is physical vapor deposition, which is an environmentally friendly alternative coating technique for electroplating. The process of physical vapor deposition is to vaporize solid metal in a vacuum environment, forcing metal to condense onto the target object, which also forms a thin and uniform coating layer. Physical vapor deposition has several advantages compared to electroplating as it is free from hazardous materials, produce no hazardous waste, no chemical to dispose, and conform all environmental legislation. Also, the coating layer it creates can be controlled to achieve specific thickness and properties, making it used in industries such as electronics or automotives. Electroplating has created a negative environmental impact to the society because the use of toxic chemicals and the formation of hazardous waste. The toxic heavy metals used during the process, such as chromium and nickels, can pollute the soil and water if they are not properly disposed. This can lead to damage of the environment. In conclusion, electroplating is the most common and standard way of plating metal. It is used in several industries such as airplane jewelry, but there are risks of chemical exposure happen during the process. Since the demand of health and environmental friendly gradually increase, alternatives such as physical vapor deposition can be tried more.